The idea of sensor is based on the working of receptors in the human body. The receptors help us to see, smell, taste, hear and touch by receiving the signals from environment and sending them to the brain which processes the information. A normal sensor works by detecting changes in its environment and converting those changes into an electrical signal. This process typically involves a sensing element which is sensitive to a specific physical quantity such as temperature, pressure or light. When the sensing element is exposed to the physical quantity, it undergoes a change in its properties such as resistance, capacitance or voltage. This change is then converted into an electrical signal by a transducer which can be processed and interpreted by a microcontroller or other electronic system. The output signal can be used to control other devices, provide feedback or display information about the measured quantity. The normal sensors help us to measure things like temperature, pressure and magnetic fields, but this measurement relies on the average behavior of many particles. However, quantum sensors are far more advanced. They help us to measure a given physical quantity with a very high precision in measurement, as the measurement relies on the behavior of an individual particle rather than the average of the behaviors of the particles. Now, to understand how quantum sensors can measure the quantities with high precision, you must know quantum superposition. If you don't know, you can check out my video on quantum superposition. Quantum sensors exploit superposition by preparing particles in specific states and then using them to interact with the physical quantity we want to measure. The interaction causes the particle states to change, and when we measure the particles afterward, we can determine the value of the physical quantity based on the change in their states. Hence, quantum sensors can measure a value with very high precision. Now let's take an example to understand this. One of the quantum sensors is magnetometer, which measures the magnetic field. Now what happens is that in the sensor, the atoms or the ions are placed in a superposition of two energy states and exposed to a magnetic field. This magnetic field causes a slight energy shift in the superposition of the atoms or ions, which is detected by the sensor and used to measure the strength and direction of the magnetic field with high precision. Okay, all this is fine, but is it really very useful and revolutionary technology? The answer is yes. It has several important uses in medicine, science and even some other amazing technologies. One of its major applications is medical imaging, in which it can be used to obtain high-resolution medical imaging such as MRI and PET scans, as quantum sensors detect smallest changes to radioactivity and magnetic fields. Quantum sensing can be very helpful in defense and security too, since quantum sensors are highly sensitive and can detect accurately the explosives, chemicals or biological agents. Quantum sensors can also help us in development of new materials with unique properties, as they can study the properties of materials at the quantum levels. Now comes its most interesting application. They will also help us in studying the quantum mechanical behavior of biological molecules such as proteins and enzymes, which would help us to understand how life operates at the quantum level, helping us to develop new treatments for diseases. This might even help us to cure Alzheimer's or Parkinson's disease. Hence, quantum sensing is very revolutionary technology. Even though it is not in much discussion these days, it will soon help us to find solutions for many problems in different areas. Don't forget to like, share and subscribe, turn on the notification bell to know whenever new video is uploaded. Comment down your thoughts on this video and on quantum sensing. Thanks for watching.